In today's lab, we're going to do several experiments with simple harmonic motion. So simple harmonic motion is a special type of periodic motion. And periodic motion is motion where an object always returns to the same point at fixed intervals or periods. Now, if the net force acting on that object is proportional to its position, and if the net force or restoring force is always directed towards an equilibrium position, then we would call this periodic motion simple harmonic motion. And there are several examples we could look at. We could have an object oscillating on a spring, or we could have an object swinging like a pendulum. And in either one of these cases, there's going to be an equilibrium position and a restoring force that pulls the object towards that equilibrium position. So in the case of the spring, we would have an equilibrium position in the center, and then a restoring force that either pulls it down towards that position or back up to that position. For the pendulum, we would have an equilibrium position in the center at the bottom of the swing, and then the restoring force would be some component of that object's weight directed along the path of the swing back towards the equilibrium position in the center, either from one side or from the other. And those are the two experiments that we're going to do in this lab. First of all, we're going to do the spring experiment, and then we'll do the pendulum after that. So if you're only doing the pendulum, then you can skip ahead and just watch that part. And if you're doing the spring, then we're going to get started on that now. For the spring experiment, there are three main parts to our setup. First of all, we need the spring. Second, we need some weights to hang from the spring. And third, we need a container or a carrier to hold the weights. So that's our first step. We need to select a carrier. And for this, you could choose a lot of different things. You could use a bag. We have a bag with a twine handle that we made for a previous lab. You could use that. Or you could use a plastic shopping bag. Or what I'm going to do is use my shoe. And I know that kind of sounds silly, but it works really well. You can hang it by the laces, and it also adds some extra weight. It acts as one of the masses or the weights for the experiment. Next, you need to select some weights. And for this, we need the total mass of your carrier, the weights, and your smartphone to add up to around 0.8 to 1 kilogram. The reason for this is we need to stretch the spring far enough that it can oscillate without bumping up against the top, but we also don't want to stretch it too far and ruin the spring. So we're going to choose some items from our lab kit, and we'll add them up so that the total mass is in that range, and the individual masses need to be less than the spring balance maximum. So the same goes for your carrier. If you use your shoe for that, then the mass of your shoe needs to be less than the maximum for your spring balance. Now just grab your spring balance and make sure that it's zeroed before you weigh anything. I've already done that with mine. And then to make this a little bit easier, I'm going to use some duct tape and tape it to the edge of the table so that I can do this hands-free. First of all, I'm going to weigh my shoe. So for that, I'll just hang it by the laces on the spring balance hook, and then I can get the mass of that. Now there's a lot of things you could use for the masses. I'm just going to be using items from my lab kit besides my shoe and my smartphone. But you could use other items that aren't in the lab kit as well. That's totally fine. The main thing is that they need to be less than the spring balance max, and they need to fit inside your carrier all at once. One of the best weights you could choose from the lab kit is the pennies. And these ones all together are around 250 grams. I've got them here in a bag, so I'm just going to poke a hole through the top of the bag and hang them from the spring balance like that. Another good weight is the steel hex nut from the lab kit. This one is fairly heavy, and it's easy to hang on the spring balance hook. One item you could use is the tape measure, and this one you'll only be able to use it for the parts of the lab where you don't need to be using the tape measure to measure distances, but for the parts that you don't need, this works great because it's fairly heavy, and you can also hang it by the belt loop on the spring balance like this. Now there's a couple other items I can use here. I've got the Hot Wheels cars, so I could hang these by their axles, just like we've done in some of the previous labs, so you can weigh each one of those that way. And then another one you could do is the wood block. And for this one, you'll probably have to put some duct tape on it just to make a little loop on top that you can hang it from the spring balance like this. Now I need to weigh my smartphone. And for this, I'm going to put the hook through part of the case and hang it that way. If you don't have that option with your phone or your case, then just use a little bit of tape and do it like we did with the wood block or some of the other items in the past. The last thing I need to weigh is the spring. And this one will not be part of the 0.8 to 1 kilogram total that we talked about before, but you will need it for some of the later calculations. The next thing we need to do is attach the spring to the edge of the table. And you could do this however you want. I'm going to use duct tape. But if you use tape, just make sure that it's not going to damage the table. I have a plastic table, so I don't need to worry about that. When you do this, just make sure it won't slide downward when we start applying forces to this. We'll need to make some distance measurements up to the bottom of the spring, and if it's sliding downward, then those distance measurements won't be accurate. Now what we're going to do is make some measurements that we'll use later when we're calculating the spring constant. So first of all, if you have a carpeted floor, then grab a hardcover book and place that below the spring. We're going to need to make some distance measurements from the book up to the bottom of the spring, and if you have a soft floor, then those distance measurements won't be accurate. If you have a hard floor, then don't worry about it. So just grab your tape measure, and we're going to measure from the book up to the bottom of the spring. So we need to choose a point somewhere on the bottom of the spring. It can't be in the middle here where it's going to expand, but we can do it somewhere on the bottom, and we need to use the same point for each of these measurements that we're going to make. So you could do the very bottom, the bottom of this loop, but that's not going to be very easy to use when you've got things hanging from it. So instead I would recommend that you choose this point right here where the bottom loop connects up with the spring. So if you choose that point, you'll be able to get to it fairly easily from the side when you're hanging stuff from it. So we'll just measure this first of all without anything hanging from it. And in my case it looks like 61.8 centimeters. So I would mark that down, and then the mass for this measurement is 0. Now we need to hang some different masses and mass combinations from the spring. And then we'll again make distance measurements from the book up to the point that we chose on the bottom of the spring. And for these we need to spread them out evenly from 0.2 kilograms at the minimum up to at least 0.6 kilograms at the maximum. And then in between we need to spread them out evenly. If you have just 0.2, 0.23, 0.25, that's not good. You want to spread them out, maybe 0.2, 0.3, 0.4, 0.5, something like that. And we need to make 5 measurements total. So I'm going to start with the carrier, which in my case was my shoe. So I'm just going to hang that again by the laces, and then we'll measure the distance from the book up to that point on the bottom of the spring. And in my case it looks like 58.5 centimeters. So that will be the distance that I measure, and then the mass is the mass of my shoe, which was 330 grams. Now I'm just going to add more mass to the shoe. So I'm going to use the steel hex nut for this, and I'll just slide it in to the bottom of the shoe, and this will increase it by, I think, around 100 grams or so. So let me just spin this back around. It seems to be easier to measure from that side. And then again, I'll measure from the book up to the bottom edge of the spring, and this time it is 57 centimeters. So that will be my new distance measurement, and then the mass is the mass of the shoe plus the mass of the hex nut. So with the hex nut, I increased it by around 100 grams, so I think I'll try to keep that spacing. If I add the 2 Hot Wheels cars and the wood block, that's about another 100 grams. So let me just put those in the shoe, and then we'll make another distance measurement. Alright, this time it looks like 55 centimeters. So that will be my distance measurement, and then the mass is going to be the mass of the shoe, plus the hex nut, plus the wood block, plus the 2 Hot Wheels cars. For the next one, I'm going to remove the Hot Wheels cars and the wood block, and then add the pennies. So the pennies were about 250 grams, so I'm subtracting off 100 and adding 250, so that will be an increase of 150 grams. So let me just put those in there. And this time my distance looks like 53 centimeters. So that will be my distance measurement, and then the mass is going to be the mass of the shoe plus the hex nut plus the pennies. Then for the last measurement, I'm going to add the wood block and the 2 Hot Wheels cars back in. So that will again increase it by another 100 grams or so, and keep that even spacing. So this time looks like 51.1 centimeters. So that will be my distance measurement, and then the mass is going to be the mass of the shoe, plus the hex nut, plus the pennies, plus the cars, plus the wood block. So for each of these different masses and mass combinations that I hung from the spring, I spread them out evenly from 330 grams or 0.33 kilograms at the minimum with just the shoe, up to a maximum of 796 grams or 0.796 kilograms at the maximum, and that was the shoe with all of the things included in it. And in between that, they were all spaced evenly or semi-evenly with an increase of 100 to 150 grams or so each time. And that's the sort of thing that you want to do. You want to be within that range of no less than 0.2 kilograms, so you can go higher than that, up to at least 0.6. You want to have them spread out across the range that works for the spring, and that will give you the best measurement and the best calculation later when you're trying to get the spring constant. The next thing I need to do is fill my carrier, in my case my shoe, with all of the items that I chose so that the total mass will add up to 0.8 to 1 kilogram. So what I've chosen is my shoe, the steel hex nut, and the bag of pennies, and then my phone. So altogether, those ones are going to add up to 926 grams or 0.926 kilograms, and that's in that range of 0.8 to 1 kilogram, so that's going to be perfect. So let me just place all of these items inside my shoe. And when I do this, I'm going to make sure that my phone is pointing up in the shoe like this. And also I want to be able to see the screen on the phone because then I can watch the graph as the data is recorded. Now when this is just hanging here like this is going to be the equilibrium position. And if it was up higher than that, then the restoring force is going to pull it down towards that position. And if it's below that point, then it's going to pull it back up towards that position. And so when we just displace it a small amount, it's going to oscillate up and down, and that will be captured on the phone, which is what we need to set up now. So just open the Fox app on your phone, and you can use the acceleration with G or acceleration without G tool. Now we're just going to start recording on the phone and then displace this a small amount and allow it to oscillate up and down for at least 4 to 8 periods. And make sure that it's only going in the up and down direction and not swaying side to side. So just have it moving in that direction. I'm going to start it, displace it a small amount, and then let it oscillate up and down like that. And that should be good enough. So now what we need to do is open the acceleration Y graph. And if your phone axes are different, then you want the axis that runs this direction through your phone. So go to the pan and zoom tools, and then pan and zoom this so that you can see some number of full periods. So the full period is going to be from like the maximum down to the minimum back up to the maximum. That would be one full period. And on the graph you'll see that as the full sine wave. So the peak to the down to the trough, back up to the peak. So just scale the graph so that you can see some number of peaks. It doesn't even really matter how many. Just try to get 4 to 8 or more if you want. And then go to the Pick Data tool and click on the peak of 1, and let me try that again. So click the peak of 1 and then pull across so that it spans several of them like that. And then you can count the number of peaks in between. So in my case I would have, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So I've got 10 peaks, and then look at the difference in time. So I've got 7.5 399,685 seconds. So I would divide that total seconds, so 7.5 whatever seconds, divided by 10, and that would give me the period of one oscillation. So it's going to be sort of an average period because each one of these may be slightly different, but if you divide the total time for 10 periods by the number of periods, then that will give you the time for one period. And that's it for this experiment. So just complete the analysis and you'll get your spring constant from the first set of measurements that we took, and then the period from the oscillation data that we recorded in the Pfiffox app. And if you're not going on to the second experiment, that's fine, but just make sure to read your instructions carefully. They will have more information than what is shared in the video. And so now I'm going to clear up what I have here, and then we can get started on the second experiment. Alright, I'm ready to start the second experiment, and this will be with the pendulum. So the way we're going to build this pendulum, we're going to have a Ziploc bag that we place our phone in, and then we're going to attach a piece of string to the side of the bag, and then the other side of the string, the other end of the string, will be attached to the side or the edge of the table. So the first thing we need to do is attach the string to the side of the Ziploc bag. And I'm going to do that with some duct tape. So just place the string so that it's centered along the side of the bag, and then tape it down with a piece of duct tape. And if you want to do it differently than what I'm doing, that's totally fine. I'm going to do it so that it has some overhanging, and then I can fold it back and tape it so that it doesn't pull out, like we've done on some of the previous experiments. Alright, so I've got the string attached to the side of the bag like this, and it is a little bit off balance because the zipper side is a little heavier, but that's not going to matter once I get my phone in it. So then just place your phone inside the bag so that it lays lengthwise along there, and then you want to center your phone so that it's centered below the string and it hangs level, something like that. So just make sure that the center of your phone is in line with the string. And that looks pretty good with mine right now. Now I need to attach the other end of my string to the edge of the table, and I'm going to do that with some duct tape. Now I have a plastic table here, so I don't need to worry about the tape damaging the table, but if you have a table that might get damaged by the tape, then just be careful about that, or maybe use a different table. Or if you want to attach it to something else, that's fine as well, but it will work fairly well with the table. So don't worry about having extra string. We don't need to cut it short. Just toss it up on top of the table. It's not going to be a problem. Then I'm just going to attach this so that we're going to start with the longest length. So I'm going to adjust it until it's pretty close to the ground. And then I'll just put a piece of tape there to hold it to the edge of the table. And I'm going to put another one up on top to hold it, and this one will be useful when we're adjusting the length later. Then I'll put some other strips on either side of the string, and this will keep it from sliding back and forth behind the tape. This is very similar to how we've attached pendulums and strings and stuff in previous experiments. And that's it for the setup. Now we just need to collect our data. So for this we have two things we need to measure. We'll have the length of the pendulum measured from the pivot point down to the center of the phone. And then we'll have the period of oscillation, which we'll measure on our phone using the Pfiffox app. Now I should probably mention that for a pendulum, the period is the time it takes to get from one side to the other side and then back to the first side. Or, right to left to right. However you want to think about it, it's the time it takes to go through one cycle of the repeatable motion that it's going to do back and forth. So let's get the phone back out of the bag, and we're going to open the Pfiffox app and start that up. Once you've got the app open, go to the acceleration without G tool, and then scroll down to the linear acceleration Z graph and tap on that. So the Z direction should be the direction going through your phone screen, and if it's not, then you may have to use a different graph. So the nice thing about using this with the plastic bag is that we can still use our touch screen once the phone is back in the bag. So just put your phone back in the bag, and then again center it so that it's below the string. So it needs to be centered directly below the string, so the center of the phone should be directly in line with the string. So something like this, that looks good. And then get your measuring tape so that we can measure the length of the pendulum. And like I said, we're going to measure from the pivot point up here down to the center of the phone. And you will probably have to somewhat approximate where the center of your phone is, but you should be able to get pretty close. So just go from right there up to the pivot point, and in my case it looks like it is 60 centimeters. So that's a nice round number. I'll just start with that number, and then we need to measure the period using the accelerometer here on the phone. So just start recording data on the phone, and then get your ruler. We're going to use this to pull the phone back and move it in a consistent way. So just pull it back a small amount, maybe about 5 degrees, and then move it in the direction that you want it to swing. So ideally we want it to all be in the one direction, and this is off from that a little bit. It's kind of twisting back and forth a little bit, but not too much. It looks like the data is pretty good. So we'll just let it go like that for at least 4 swings, 4 full periods, but if you can do more than that, that would be good. So that should be good. Let me just stop that and then pause the data recording. Alright, so on the pan and zoom tools, I want you to zoom in so that you can see some number of periods. The period is going to be from one peak to the next peak, or from the bottom of the trough to the next trough, something like that. So just scale it so that you can see some number of peaks, and then we're going to count them and then get the time difference between them. So in my case right now, I think I have, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right now. So that'll be good. Then go to the Pick Data tool, and what you're going to do is tap on one peak and then slide your finger across until it gets to the other peak on the other end of your screen. So I've spanned across 10 full periods, and then I'm going to get the time difference and divide by 10 to get the time for one period. So I've got 15.672199 seconds, and then I would divide by 10 to get the period for just one of those. So just write those down, get that data, and take a screenshot. That's probably an easy way to record the time and the number of periods for that. So I just clicked off of that, and then I'm going to go back and leave the experiment so that it clears all the data and resets the graphs. Then I'm going to go back to the acceleration without G tool, and again scroll down to the acceleration Z graph. Now we need to adjust the pendulum length. And for this, you may just be able to grab the string up on top of the table and pull it back so that you can shorten it. If you're able to do that, then that's good. Otherwise, you can loosen the tape and readjust it that way. Okay, so I was able to just slide that. That's a nice way to do it. And then just tighten the tape again so that it's not going to slide while you're doing the experiment. Then grab the tape measure again, and we'll measure from the pivot point down to the center of the phone again. So now I've got 56 centimeters. Actually, I'm going to shorten that just a little bit more. We want to get down to around 30 centimeters at the end, and we've got 5 measurements, so maybe I'll try to do around 5 centimeter differences every time. Okay, so center of the phone, back up to the pivot point. Now I've got 54.5 centimeters, and then I'm going to start the phone recording again. Okay, so that's recording. I use my ruler, pull it back a little bit, and then move it in the direction I want it to swing. Uh-oh, it's spinning. Okay, so that's not what we want. We want it to just move in the one direction. So let's try this again. Okay, that's pretty good. can't see the graph, but just based on its motion, that seems like it should be good. All right, and that should be long enough. So let me just stop that. Again, pan and zoom. Zoom in until you find the good data. Then I'll use the pick data tool and span across some number of peaks. And this time I've got, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9 this time. Okay, so I've got 13.342072 seconds, and then divide by 9, and I would get the length of that period. So if I was doing this experiment, I would do it 3 more times so that I have 5 total, and each time I would shorten the length of the pendulum, and then put the phone back in, measure the pendulum length from the pivot point down to the center of the phone, and then I would start recording, let it swing back and forth, starting it with the ruler, and then stop it, scale the graph so that I can see some number of full periods, and then span across that with the pick data tool, get my time difference, divide by the number of periods, and get the period for that pendulum length. So I would do that for each time, record the pendulum length and the period, and that's it for the experiment. Then just do the analysis and you'll find an experimental value for the acceleration of gravity, and that's it. So just read your instructions. They've got more information than what I shared in this video, and good luck on your experiment.